Hello all and welcome to the supplemental video for the conversation piece, the sequential conversation piece that I did. I just want to go over some of the tools that I used while making this and how some of the other components work. If you read the website, you'll know that I built this by hand TET RAM generator. So basically what it does is it will generate a RAM based off the inputted frequencies here. So you could choose the TET, which is tones of equal temperament. And what we'll do here is right now we have loaded in a 12 TET system. So the first octave of your temperament you have to input by hand into a ROM and then load it in. And then what you do is you go up here and you, in hex, put whatever that TET is. So 12 is C. And then what we could do here is we'll do octaves. Let me turn the clock off real quick. We'll put in 2, or let's put in 3. And then we already have the constants here. These shift over a tone by 2 in hex, which is essentially doubling it. So let's reset these registers. And then we will hit play. And hopefully we will see this RAM over here generate some tones. So right now for the first octave, it's just copying them as is. And then we should be seeing them get doubled. So yep, we've got 68 here, which these are all rounded, so that would be double of 37. Or excuse me, not 68, 6E is double of 37. And yeah, it's just going through. This does take a while. The more octaves you have, the longer it takes to do. But it is pretty cool that you could do that. And then once you're done, which it's done now, there's no more copying. You would stop the clock and then you could come over here. And I believe you have to have the selection tool and you could save the image. I have a ROMs folder, but you would just write whatever you want and then that would be done. I didn't get to implementing a random TET for the intervals, but this was my start on it. This is the synthesizer and its full form. And let's look at the code that generated this. So all I did was put this first one up here, which you could see on this one. This one does have 2 here because I tried to implement a tone slider. So let's see if I can't get it to work. I'll turn this on. Oops, I need the selection tool. And so that would have been a pitch bender, but it's very hard to control and not very intuitive. So we'll turn that off here. But this over here on the left is the one that I did by hand. So it has the sine wave, square wave, triangle wave, and saw wave here. These indicators are just to hook up. This is the volume. This is the selector for which buzzer you get, which waveform. And then the zeros here because I just store one single note in the ROM so that I don't have to do any tricky math and logic to get a note from a particular ROM. The smallest ROM you could have is 2 bits wide in address, so that's why there's 4 inputs here. And then that note goes out into the buzzers. And then each note has a player that goes into this demux that you would then select with this. So let's go to the code for that. Let me cd out of this one and let's go into the scripts. So we have this tet calc at the very bottom. Let's look at that one first because that's actually how I generate the notes. So we need the starting address, which if you let me jump into ARAM so you can see what I'm talking about there. Let's do this one. So all RAM and ROM image files and Logisim have this header with the addresses on the side. There is 16 in a given row, and that's why it's going up by 1 in the second column. These are all hex addresses. When I initially started this project, I didn't know too much about splitters, so I made every single thing 14 bits long, so this file is very huge. You can see that we've got 1025 addresses just in this one RAM. But those are generated from the tet calc. So here's the address again, here's the starting note, which is A0 or 55 hertz. Here I have a starting note different because I've changed this out every time I generated a new one based on different circuits I had. So this would have been for the scale listener ROM. Here we're opening up a file, so every time you change the tet and octave, it generates a new file. I do have these commented out sections that you can, as a command line, put these in. So let's actually demonstrate that, and I'll comment these ones out. So if I run Python tet calc with 2 and 5, let's do that. Generated a new ROM that wasn't here before, and here is 5 octaves in the 12-tone temperament system. Just to show you, let me remove that 12, and we'll do the same thing, but this time we'll make it a 24 equal temperament system with 5 octaves. And let's open up that. So as you can see, there's about double the amount of notes, which makes sense because there's double the amounts of notes per octave. So back in the tet calc, so that's what these are, and that's why there's this import library for system so that you could run command line arguments on this. So this is that header that you saw at the beginning of the ROM file. And then I just have this for loop that goes from 0 up to the highest octave and tet in the given tet. So the frequency notes are generated by this 2 to the power of the note divided by the tet times the starting note, so that's what shifts it over. And then this part is actually not needed, but it's nice to have the zeros there in case you have other stuff. So having these leading zeros, so for example, the first note is like 3A, I believe. This just puts 2 extra zeros in front of that so that they're all equal width. Every time a note has a remainder of 0 when divided by 16, I put a line break in there and put the new address, which you saw before. So you saw that 0, 1, 2, 3, 4 on the left-hand side. That's the new addresses. That just tells Logisim where to look and how the ROM should behave. But other than that, we're just storing the frequencies. That's what these curly braces are. And then this fills it up to that entire 2 to the power of 14 addresses. That's what this one down here does. This one just fills up a single line to zeros. So let's say we stopped at 12 notes on a given line. This just fills this up to get to 16. And then we just write the file. So here, this is the ROM one. So let's quit out of here. Let's look at the next one would have been, let's do the rand notes real quick. So this one generates those random notes and intervals for the ear training game. We start at 440 because these notes are just a little bit easier to hear. It's harder to hear low notes, so I wanted to start a little higher. It makes the ear training a lot easier. So we start at A4 instead of A0. And then I have this notes list that we just append to every single note in the given tet up to the octave. For the ear training game, I only did 3 octaves worth. But then we now generate 2 separate strings, one for the notes and one for the intervals, as you can see up here. And then I have the memory bits in this one. This just generates an entire 2 to the power 14, actually 2 to the power 13 pairs of notes and intervals. So there is quite a lot of random choices to pick from here so that the exercises you don't ever see a pattern. So here's the script. We just generate a random number from the given notes that we have. So this is all the possible notes you could pick from. And then here we're picking a random note and a random interval. And then this is just some math to make sure we don't go over the octaves or below the octaves. Down here, we are storing the note and the note slightly higher than it here, and then we're storing the distance between those notes, which is here, down here in the second ROM. So we have a frequency ROM and an interval ROM. Since ascending and descending are the same interval, the same distance, that's why they're stored twice. So when you're doing the descending intervals, you're actually looking at this one, and when you're doing the ascending, you're looking at this one. But they're the same thing. It just makes the math and the logic a lot easier to store it twice. This top one, just like the last time, if the pair is divided by 8, has a remainder of 0, it's adding the new address, so that's because everything's coming in pairs now, so that's why we divide it by 2 instead of the 16 from before. Otherwise, we just print as normal, and then we save the 2 files. So next we'll look at the ROMs. So the ROMs I actually don't save to a file. As you can see here, I just print it out and then I use some command line arguments to store those into a file, but this is because I kept having errors in this one, so I wanted to check what was happening and print directly to the console instead of storing it in a file, which is just a waste of operations. But this one is quite big, so here you again choose the temperament system and the octaves. Before I go further, this is actually what we were looking here at Logicen. So the thing you're going to see on screen is actually all the information on this ROM right here, so that we could generate this circuit here. Let me scroll out. That has all the notes, so A through G sharp or A flat, and then all the different octaves, which are the rows. So you'll see that here. So let me jump back to Logicen real quick so that you can see what I'm talking about. So if we look here, this top pin right here I believe it's this pin right here, has the coordinates 140 and 160. We could actually check that by clicking on it. Yep, 140 and 160. These are the coordinates down here of each of the objects. So I just clicked, I did not click on these. I opened up the file and found that these were the smallest coordinates, and then these larger coordinates here, 480 and 960, are the largest on this single one. So that basically gives you up here, down to here basically. And then I do a little off shifting of 50 so that we could have the space in between them like you see here. So this is about 50, a jump of 50. So now we're writing the Logisim circuit. So let me actually open up one of those so you can see what I'm talking about. Let's jump out of here and let's open up the SecV. So this is what your Logisim file looks like. It's an XML format type file. It has the project header and what version of Logisim you're using. This first part, lib, is the libraries that you see on the side, so you probably know the wiring, the gauge plexers, and so on. And then after this is where these are extra tools. But once you get to circ, these are the actual things on the side. So like this is a circuit and this is a circuit and so on all the way down to here. These are the ones you make and what are stored in the files. So each of these has a name and a look. So all of these A's are attributes and they store all the meta content basically. And then we have the locations of all the stuff. So let me run down to something that we could easily see. So here's a register and here's the ROM. I'm trying to find, let me see if I can't find a buzzer. There we go. So here's the buzzer location at 810 let's see what circuit this is. Oh, it's not letting me scroll. There we go. This is the test circuit. So we have a buzzer at those location points that we see right here. So basically I just copied and pasted an entire circuit of the one that we viewed right here. I copied and pasted this one into a Python file, which we could see right here. So you're just seeing all of this information that I'm storing into a screen. And then here is, this is the meta content from before with the footer, so they all end in the / of the same name. But here is the actual stuff on the canvas. And all I'm doing is changing the coordinates by from the original, which is what you see in orange, to the offset. And I do that for every single component on there. And what happens is everything that you see for the X offset just shifts it by a note name value. So this would be the A, B, C, D. Obviously Python doesn't know that, so I'm just shifting it by integer values. And then the Y offset is for the octave, so those are the rows. And those happen all within these two for loops, these nested for loops. So the inner one generates all the column and the outer one generates all the rows. And yeah, so you would basically clearly put in what temperament you want with the amount of octaves. So this one with the 3 is when I was trying to make the note bender, but the one you see in the synthesizer you see here is obviously 8 octaves and is what I used to generate this. This was hand-drawn, or hand-drawn using the customization tools that you see up here. So I just did all of that and no Python scripting there. But this is how I generated all of these, so I didn't have to do them by hand and copy and paste a whole bunch of times and connect everything. So the only thing I did by hand here is put these values here, and then the lines that are in these upper rows here and here. So all in all, about 16-ish lines drawn by me, and the rest was Python. So that's pretty cool. The next ROM that we have is the last one is the Grand Staff. So all this does is this generates the frequency and the numbers for the note reader game. I didn't want to do this multiple times, and in case other people were interested to do different temperaments or do larger octaves, they are more than welcome to use the script to generate everything. This just generates the ROMs. You still have to do all the hand drawing, so let me see if I can't find that circuit. Here's the circuit for the note finder, so we have all the notes and their octaves over here. These are the outputs for the RGB lights. These are the inputs, and then what you would still have to draw is a grand staff like this and do all the ledger lines yourself. But this is what generates the ROM file for those, which is very convenient because it is annoying to figure out which notes are actually on the staff and which ones aren't. But I believe that's all the tools. Let me check to make sure there's nothing else I'm missing. No, it looks like that's everything here. And I believe that's all the things here. The only other things I didn't show were counters. I just used synchronous counters, basically copied and pasted from the lessons. For 8, 6, 7, and 16, the scale selector just behind the scenes. We have all the scales that you can choose, the different counters. So 8 is for the all the 7-note stuff plus the octave. There's 6 for the pentatonic plus the octave. There's 7 for the major and minor blues scales. And then there's 16 for the melodic minor because it goes up and down, and that's why there's also a subtractor here, because the subtractor subtracts off the intervals to get back down to the root note. And I believe that's it. Yeah, I don't think there's anything else. If you have any questions or comments, please put it in the comment section, and I will try to reply. But thank you for watching, and have a nice day.